go through. Do you remember we said at the end of last lesson that logarithms are the inverse of exponential functions? So I would say we're actually talking now, not just logarithms, but we are talking logarithmic functions. Okay? So we're not just talking the laws of logarithms, we're talking about logarithmic functions. So do you remember last time we said that we've got functions, so if f of x was 3x minus 5, we've got the inverse function, whether you want to use an x or a y. We had that discussion, we don't need to go through it again. Just going to use the convention for our exam, so the inverse function would be...
X plus 5.
No, yeah, sorry.
Over 3.
Over 3, well done. I thought I'd written a plus 5, but I haven't. X plus 5 over 3. Awesome. Yes.
So you said you would look up if, like, in our mark scheme,
I haven't done it yet. Yeah.
Sorry, this is kind of off topic, but you know.
Should we stick to topic for the moment?
But it has to
I'll
do
come back
with
to it at the end.
Okay.
Alright, you can ask me at the end when I've gone. If I said g of x is x squared plus 2. Jasmine.
It would be root x minus 2.
Sorry, say it again. Root of x minus 2 or root of x minus 2.
Yeah.
Which one?
Root of x minus.
So the square root of x minus 2. Like that?
Yeah.
Good. Yeah.
Wait, why wouldn't it be just the x though? Why is it all?
Because if you think about what you do to x, the first thing you do is square it, then you add 2. Okay, so if I go back, I start with x, I minus 2 first, and then I square root. So the square root has to happen to the minus 2 as well, because the minus 2 has already happened. Okay? So that's when we rearrange things. Now, Chiara, is that a function or not? Is g to the minus 1 of x, is it an inverse function?
To the g minus 1 x?
So this is a function.
Yeah.
This is a function.
Yeah.
This is a function.
Yeah.
It just happens to be the inverse function. Is this also a function?
Yeah.
No.
Ooh, some people are taking the clue that I've asked that one, and obviously that's not
Because
yes.
all of them are functions, but is that
Why
one?
is he asking that one? Yeah. You've not done your research?
I did, and they said nothing with square as a function, so the fact
Why?
Because a square is
I'm only going to touch on this very briefly.
operation.
The only thing is you said that
Because
that
a
one's a
square
function,
is
so that
not an operation.
You're not making
Right, there's one reason. Alright, you might have read something called the vertical line test. Alright? You might have read the vertical line test. And basically, we're only going to touch on it because you'll need this for next year. And you'll do it again next year. We either have a one-to-one function, a many-to-one, or a one-to-many. Okay, now what does this mean? Well, if it's a one-to-one, it means one input will give one output only. All right?
relationship.
Yeah, exactly. If it's not a function, it's a relation. So you've already done this in IT.
Yeah.
See the links?
I failed it today.
Right? So if one input will give an individual output, like a linear function. If I put x is 3 into a linear function, I only get the y value of whatever out. No other x value will give that y answer because I've got a straight line. It can't happen. However, if I've got a quadratic function with a curve, okay, if x is minus 2 or x is 2, they give the same answer, right? Because 2 squared is 4, minus 2 squared is 4. So that would be a many to one situation. Alright? And that's fine as well. That's a function. Many to one is a function, fine. The one to many, what do you think it means?
You put one number in, but you get more than one answer out.
Yeah. Means
How?
how? Okay.
It's
Square
like a
root.
line. There's so many points that we can only see two.
That got really deep.
Are you listening? Square root. What's the square root of 16?
4.
Negative 4 or
Oh.
4.
So the inputs into my square root will have two possible answers. Therefore, it is impossible for me to be 100% sure that I am inversing the quadratic function. Right? Because I can't tell you whether you put 2 in or minus 2 in. Does that make sense?
Yeah.
So, we have an inverse. It is a relation. It is not a function because it has two possible solutions. There are two possible solutions for it. So it looks the same. We deal with it exactly the same, but it's not called a function. Yes, Guy?
So what would be the inverse of G?
That is the inverse. Right, this is the thing. It is the inverse. I would write it as the inverse. Alright? Now you'll notice that in an exam question, for instance, they'll never say, write the inverse function. They'll say, find g to the minus 1 of x. They won't use that word function. Kept out of it, IGCSE. They'll just say, find f minus 1 of x, meaning find the inverse. Right? Just adding it to your knowledge now, ready for IB, that x minus 2, the square root, is not a function. That's all. Does it make any difference to anything else you do? It's just, it will have two possible solutions. Yeah? If you have to find the inverse, there are two possible solutions. So therefore, we do not, this is not a function. Okay? And it's because it's a one to many. So that is not a function. It is a relation. So it's quite good that you've been doing that in IT. Yeah. Right. But we still do exactly the same thing. We do the inverse, we do the inverse operations. Right. It's just whether it's called a function or not. Right, let's get back to then. I said to you, well, what if we have another function that is in the form, all right, let's say 2 to the power of x. Okay. So in all the others, like we've just done here, we can write down a flow diagram. I put x in, I do this to x, then I do that, and I get this answer out. How could I do a flow diagram of 2 to the power of x? What do I do to x?
Oh, we talked about this.
Yeah,
Yeah,
we did,
the
yeah.
exponential function.
It's an exponential function, but what do I do to x? I don't do anything. I use x to do something to 2. Do you get that?
Yes.
Right. So how can I write a flow diagram? I can't put x in and go, fill my butt. What do I do there?
We don't know.
Well, I don't know. Because I don't know what x is, so I can't tell you what I'm doing with it.
So you have to use 2 instead?
There's like a magic way to
So
do it.
2's, no, it's a difficult one to explain in the same way. That's why you really have to understand. Yes, ma'am.
Don't you have to like okay, never mind.
So, the trouble is then, you're right, this is an exponential function. Alright? It's an exponential function. They behave in certain ways. Those of you that do economics, those of you that do chemistry, physics, you've got half-lives, you have done that? Your half-lives of radioactive material. If you're doing biology, you're talking population growth and all that kind of thing. They're exponential functions. A very famous one that you need to get used to using in the IB would be, I'm going back to f of x, would be e to the power of x. You've seen that on your calculator? E is just a number, like pi. Now, the 2, if I've got an exponential function, 2 to the power of x, what happens every time I increase x by 1? So 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. What happens every time? By what?
By the amount that.
So how do you increase a power by 1? So 2 to the power of 1. What do I do to 2 to the power of 1 to get 2 to the power of 2? Times it by 2. So I double it every time, yeah? So 2 to the power of x is a doubling function, right? That's why we kind of say it's a growth function, because whatever I had before, I double it. Kind of say that with rabbits, yeah? You got 2 rabbits, give them 30 seconds, you've got 4 rabbits. Then you've got 8 rabbits, then you've got 16 rabbits, and so on. All right? It's a doubling function. Now the trouble is, nature is not like that. And this is one thing about maths. Nature is not like that, the doubling function. Things don't just magically, nicely packaged double. But people did research and they did find that actually in general, they do almost double. They slightly more than double. I think more or less. You'll have to tell me. They found this common, do you remember what it's called? When you have a geometric sequence which doubles every time. The doubling is called the common
Coefficient.
It's not difference because that's when you add the same. What's it called? A common
Increase.
ratio.
Ratio.
Remember it? They found this common ratio of E. Have you got a calculator? Can you press the E button and tell me what it is?
I know the value of E.
Tell me what E is.
2.71828.
2
718, yeah.
Okay, this is a nice. Guess it.
I did a little multiplication to see if it works. So I did.
Just press the E button on your calculator.
Is this the answer?
Yeah.
Oh, wait, is this the answer?
0.931.
No.
Click on EX.
Put E, and if it asks you for a power, just put E to the power of 1 and tell me what E is.
2.71.
Oh, I got it. I was right.
Yeah.
Zero.
2.71.
828.
Oh, I did to the power of 3 and then I cubed.
Yeah, that's fine. Yeah. All right. Now, nicely done. Put on pi day because this is another number like pi. Right. Pi is a ratio of circle diameter to circumference. E is a common ratio found in nature. All right. If you look at population growth, if you look at half-lives, things that are found in nature, generally they are a ratio of E. All right. Which means they almost treble rather than double. Okay. Population growth of humans, of insects, whatever. If you look at how flowers grow and things like that, the way have you heard of the golden ratio as well?
Yeah.
All linked with this. So this is a mathematical number, but created by nature. So for you to discuss in TOK and
It's like
IB1.
E as an environment.
So E is just a number. It's another ratio. So we have these exponential functions and we want to be able to find x. I want to solve. So do you remember I said to you, if we put x in and we do 2 to the power of x and I get an answer of 15.8, for instance, and I said, right, we've got to go from 15.8, do the inverse function and get x back. I want to know what x is. However, there's no what do I do to x to undo. So it's an inverse process. And what is that inverse process? It's not E. E is like I'd be doing the same thing. So if I did x and did e to the power of x and got 13.732, what would I put, how would I get the inverse, okay, the inverse function, what would I get x as? What would it be? So e is just another number. So how do I find the inverse function of 2 to the power of x? I did mention it briefly at the end of last lesson.
Log
3.
stuff.
So
Wait, what did you want?
Log X.
log
Log 2
and bracket x.
log 2 equals.
So in this case, it would be log to the base 2 of 15.8 will equal x. It's the inverse. Do you want to do that for me?
I'm sorry. I'm really
It's log.
Do it quick then. Always find a time when we have to do some work. Sophia's gone. Have you done it? Use your calculator. You're going to use your calculator.
There is no equals button. You don't have to. All you have to do is the first part.
Just put log. If you press your log button, I think it gives you a little square, doesn't it, to put the base 2 in. All right, we need to discuss this vocabulary in a second. Then type in your brackets 15.8. Press enter. It tells you what x is.
Log base and then.
So x is
3.9815.
blah blah blah. Okay. Now what does that mean then? Well, that means that 2 to the power of 3.9815 blah 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 should equal 15.8. Would you like to check that for me?
That's not correct. It's 38185.
No, 3.98185.
I meant 98185. Yeah.
Okay.
We're missing an 8.
981. We're obviously going to estimate.
50.
Does it work?
Yeah.
You just put the answer button.
Yeah.
You just click the answer button.
Okay, so it's the inverse. We got that. So we need to look more in detail. Now, just to tell you, again, this is not in this course, but I'm challenging you. The inverse, how do you think I would do this one? So it'd just be log to the base
E.
bracket to solve 13.732 equals the x value. Okay, now, just to introduce you, we don't write log to the base e. It's too important. Okay, it has its own thing. We don't write log to the base e. Does anyone know what we do instead of log to the base e?
What's this?
Nope. E is better than 2.71 because that's rounded. It's letters, so if you're going to tell me numbers, it's not right.
Is it in? Is it that?
It's what?
In.
It's
Or
not in, but
N-I-N.
yes, it's not an I.
L. One N.
L for,
Logarithm.
it's actually
Nature.
ln. Right? Log to the base e is called the natural
Oh yeah, I see that.
logarithm.
Oh, I see it.
I got the thing.
It's there on your calculator. It's so important it has its own button.
Whoa. Talk about importing.
So this is called the natural logarithm.
Okay, I got underlined.
Right? It's an ln.
I'm sorry,
I've-
what's in the brackets of F minus?
X. Okay. Make sense? Yes.
Okay. Oh wait, never mind. I see what I did wrong.
Now, yeah, so we can use our natural logarithm button. As you go through your years, you're going to use these logarithms much, much more to solve problems and things. So, not so much in this course, but you will. Now, what we need to do is actually learn about how we simplify with logarithms, because they're a function. Like x squared, you can collect like terms, like x's, linear functions you can put together and solve them. We are dealing with a logarithmic function, therefore we need to be able to deal with them. We need to be able to simplify them, we need to be able to cancel them down, we need to be able to write them in a different form, just so that we can work with them. Does that make sense? So we're doing the same thing that we would do with any other function. Alright, so that's the next stage. And I'm just going to rattle through them now, because I'm sure you'll understand. Alright? Because now you know what they're about. But go on. Do you need to go somewhere or just about this?
No.
Okay.
I'm just kind of confused.
It's because you were out of the room.
What? No, this was before. Where do you get 15.8 from?
I gave it to you. I just made it up. Yeah. Okay. Before we talk about it, I just want you to remind me, please, of the laws of exponents. So, if I've got a to the power of m times a to the power of n, we have
n. Minus n.
okay.
am times n.
Can you just put mn?
1 over am.
Wow, I'm so cold.
Okay. You can, but I'm writing it just to do it. Okay.
Now we do the opposite.
So there are some others, aren't there? Yeah. So a to the power of 0 is another important one. Is 1, and so on. All right. So what I'm going to do, I'm going to write down the laws of logarithms now, and you'll notice the link, because obviously logarithms should link with exponents. Yeah. It's the whole point of them. So just to make one thing clear. This A here is called the what again?
Base.
That's the base. Alright? So you'll understand when we talk, right? That is a base. That's the base of the exponent. Right? It helps you. Do you know this whole I say root 3, you guys say surd 3? It helps understanding if you can start using the correct terminology. So when I say log to the base 2, right, it helps me because that makes it link to it's a to the power of, because a is the base. If you just say log 2, then it starts getting confusing. So get used to saying log to the base 2. Right? Now, one of the laws, log to the base, I'm going to use other letters so not to confuse. So let's say log to the base, well, I'm going to use a. Log to the base a of x, right, plus log to the base a of y. You'll notice that the base has to be the same, just like the exponent base has to be the same, right? What do we think might happen?
Do you mean times or
No, I mean plus, but
Are they gonna add together?
no.
Okay.
Yeah.
Oh, sorry.
It's going to be log to the base a of x times y.
Oh my gosh, because you times them and it comes out as adding.
Justin, finish your sentence.
Log, I got it. Log to the base a of x minus log to the base a of y is log to the base a.
X over y.
Oh my gosh.
I see why you mean it's important.
No more. Please.
Okay. So
Right.
Wait, why don't we use
Fractions and adding with exponents.
Oh yeah, why don't you? Because exponential means repeated multiplication, doesn't it? That's why I can add the exponents together. But if I do a squared plus a to the power of 3, I don't have a to the power of 5, do I? I can't just treat the add as a multiply. Can't do that. So that's why we don't have adding. But you can see how it's the opposite, yeah? So if you know your exponential laws, you know your laws of logarithms. Okay? Now a couple more that you can see the link but might not be quite so clear. Alright? We would have that log to the base a of x to the power of n, okay, is the same thing as, any ideas?
Oh wait.
It's going to be linked, but because I've not got x and y, it's making it a bit more difficult for it to see. It's going to be linked with this one, isn't it? Because it'll make sense. Layla?
Maybe it's I forgot that like sign, but you know, like when you do the opposite of cube rooting.
No, it's not that.
No,
No.
not like that.
So would it be log to the base a bracket x times log to the base of a bracket 1?
No. Trying to think where that comes from. No, it wouldn't be. Good guess. But no. You do this all the time. It's actually...
I sound smart in my head.
N log a x.
So n times log to the base a of x. So it's n times. So you notice here, look, you've got the power. You multiply those two powers. So we have, you know, the shortcut teacher way would be to say, oh, you put the n in front. Okay.
Wait, do you leave the x there?
Yeah, the
Or
x
do you times
stays.
them all?
No, it's now. It's now. Yeah, we can put. We don't have to, but we can put the x in the bracket. So it's n times log to the base a of x.
So log a x is together.
Yes.
Wait, so when you're
When
doing
you do that with logarithms, is it the same reason why you do it with limits? Like when you try to do it, you put the n there and then you subtract it by 1 on top. To find the answer.
That's differentiation.
Different,
That's
yeah.
different.
That was different.
All right. Now, log to the base a of a equals
a log a.
A squared. 1.
1.
Oh my
Because you're a divider.
Do you remember what we were doing before? We were saying how it's an inverse, isn't it? So what I'm saying is log to the base a, so that means a to the power of. What I'm trying to solve is the power, so I'm saying a to the power of 1 is a.
Oh, so
But then
like
wouldn't
the
it be
what's
a
in the
equals-
bracket is what it
No.
is.
A to the power of 1 is a. Remember, the logarithm is the inverse function. So I'm saying that a to the power of 1 equals a. So therefore the inverse is to say log to the base a of a is the power. That's what I'm trying to solve for you. Don't forget that you're using a logarithm to solve for the power.
For example,
Explain that again.
Yeah, after Jasmine spoke.
so if we have an example for, let's just say log to the base of 2 times log to the base of 2, 2.
So log to the base 2 of 2
That would just
equals 1. Yeah.
Okay.
Yes. Then?
So it has to be the same like.
So the number and the base.
So what would
So do
happen?
you remember? Let me try and explain this for Hayley. So remember I was saying that if we have, so I'll explain this one, 2 to the power of x equals something, yeah? So I'm saying 2 to the power of x equals 2. So what value of x would give me that? So I don't need to do it, but if I were to do the inverse, I'm saying that stick the 2 in. So I'd be saying what value of x goes into 2 to the power of x to give me the 2. So if I colour code it, this 2 is that 2, right? And then this 2 is here. So if I do the inverse, right, I'm doing log to the base 2, what goes into it? That 2 will give me the x value. So this 2 is the base, log to the base, and this 2 is what you put into that function. Yeah?
But how is he into 1?
Because 2 to the power of what is 2?
Oh.
2.
So.
Anything to the power of 1 is itself. Yeah?
Yeah.
And just finally, we're going to do a lot more work on this, but I'm going to ask you to make sure you've reviewed these. The last one is log to the base A of
-8.
How could I write something that shows me that a to the power of 0 is 1?
Is that it? Bracket 0.
So log to the base A of
0.
1 equals 0.
Oh.
Make sure you read and review all these, and then we'll really hit it with simplifying stuff next lesson that we have. Test on Friday. Yes, Layla.
So you know